40 million Reese's peanut butter cups are produced daily. That's enough to circle the Earth's equator twice if laid end to end. How does a factory manage this massive output? Let's take you inside the Reese's production line to see how these beloved treats are made on an industrial scale. The process begins with two main ingredients, specially formulated peanut butter and a unique blend of milk and dark chocolate. But it's not just any peanut butter. Each Reese's cup requires about 70 peanuts, specifically a type called the runner peanut. These aren't your average legumes. They're chosen for their high yield and uniform size. Now we move on to the factory floor. Here's how it works. A complex system of machinery transforms these simple ingredients into millions of perfectly formed cups. The process involves precise mixing, molding, and temperature control. As we explore further, you'll see the engineering marvels that make this massive production possible. The journey of a Reese's peanut butter cup begins with the humble peanut. But not just any peanut will do. Reese's uses a specific variety called runner peanuts, prized for their high yield and uniform size. These characteristics ensure consistency in both taste and texture across millions of cups produced daily. Once the runner peanuts arrive at the factory, they undergo a carefully controlled roasting process. This crucial step not only enhances the flavor, but also prepares the peanuts for grinding. The roasting temperature and duration are precisely calibrated to achieve the signature Reese's taste profile. After roasting, the peanuts are ground into a paste. This is where the transformation from simple legume to the heart of Reese's begins. The grinding process breaks the peanuts down into a fine, creamy consistency, but it's not quite ready yet. To create the distinctive Reese's peanut butter, additional ingredients are needed. The ground peanuts are transferred to large mixing vats. Here, sugar and salt are added to the mixture. These ingredients aren't just for flavor, they play a crucial role in achieving the perfect texture. The sugar helps to smooth out the peanut butter while the salt enhances the overall taste profile. Now let's talk about the machinery involved. The mixing vats are equipped with high shear mixers. These aren't your average kitchen blenders. High shear mixers are industrial-grade machines designed to break down particles and emulsify ingredients on a massive scale. They're capable of creating a uniform product even when dealing with tons of peanut butter at a time. Ever wonder how they get the peanut butter so smooth? The answer lies in the precise control of mixing time and speed. The high shear mixers operate at carefully calculated speeds for specific durations. This ensures that every particle of peanut is broken down and blended perfectly with the sugar and salt. The result is a completely smooth, lump-free peanut butter that's consistent across every batch. The mixing process is a delicate balance. Mix too little and you'll end up with a grainy texture. Mix too much and the oils in the peanuts can separate, ruining the consistency. The engineers at Reese's have perfected this process over the decades, fine-tuning every aspect to achieve peanut butter perfection. What sets Reese's peanut butter apart from what you might spread on your morning toast? It's smoother, creamier, and slightly sweeter than traditional peanut butter. This unique formulation is key to the Reese's experience. The extra smoothness allows it to blend seamlessly with the chocolate shell, while the added sweetness creates the perfect flavor balance. The peanut butter's consistency also plays a crucial role in the manufacturing process. It needs to be fluid enough to be pumped into the chocolate shells, but firm enough to hold its shape once cooled. Achieving this balance requires precise control over ingredients and mixing processes. Temperature control is another critical factor. The peanut butter needs to maintain a specific temperature throughout the mixing and filling processes. Too warm, and it won't set properly. Too cool, and it won't flow into the shells correctly. Sophisticated temperature control systems monitor and adjust the peanut butter's temperature at every stage of production. Now that we've seen how Reese's creates their signature peanut butter, let's explore the chocolate making process. Reese's uses a unique blend of milk and dark chocolate for their cups, combining the creamy sweetness of milk chocolate with the rich depth of dark chocolate. This blend is crucial for achieving the iconic Reese's flavor profile. The chocolate making process begins with melting. Large vats heat the chocolate blend to a precise temperature, ensuring it becomes fully liquid without burning. This step is critical as even slight variations in temperature can affect the final texture and appearance of the cups. Once melted, the chocolate undergoes a crucial step called tempering. This process involves carefully cooling and reheating the chocolate to stabilize its structure. Tempering is what gives Reese's cups their signature shiny finish and satisfying snap when you bite into them. It's a delicate balance. Too little tempering results in dull, soft chocolate, while over-tempering can make it brittle. The chocolate mixture isn't just cocoa and sugar. Several key ingredients are added to enhance its properties. Vegetable oil improves the chocolate's fluidity, making it easier to work with during the molding process. Cocoa butter contributes to the smooth, melt-in-your-mouth texture that Reese's fans love. Soy lecithin acts as an emulsifier, preventing the cocoa and cocoa butter from separating and ensuring a consistent texture throughout the cup. Now let's look at how this perfectly tempered chocolate becomes the shell of a Reese's cup. The process uses a specialized spraying machine that coats pre-formed molds with a thin layer of chocolate. What sets this machine apart is the ability to vibrate. As it sprays, the machine vibrates to ensure the chocolate spreads evenly across every surface of the mold. This vibration is key to achieving the uniform thickness that's characteristic of Reese's cups. The engineering behind the molds themselves is equally impressive. They're designed with a subtle lip around the edge that allows excess chocolate to flow out. This clever feature ensures that each cup has a perfectly smooth bottom and a consistent shape. It's a small detail, but it's crucial for maintaining the quality and appearance of millions of cups produced daily. After the initial chocolate layer is sprayed, the molds move to the next station where they're filled with the peanut butter we explored earlier. The temperature of both the chocolate shell and the peanut butter filling must be precisely controlled at this stage. If either is too warm, they'll mix together, ruining the distinct layers that make a Reese's cup what it is. Once filled, the cups return to the chocolate sprayer for their final layer. This top layer seals in the peanut butter and completes the cup's shape. Again, the vibrating action of the sprayer ensures an even coating. The filled cups then enter a cooling tunnel. This carefully temperature-controlled environment allows the chocolate to set properly, maintaining its temper and shine. The cooling process is gradual to prevent any sudden temperature changes that could affect the chocolate's structure. As the cups emerge from the cooling tunnel, they're nearly ready for packaging. But first, they undergo a final quality check. Any cups that don't meet Reese's strict standards for appearance or weight are removed from the line. The entire process, from melting the chocolate to the final quality check, is a testament to the precision engineering required to produce Reese's peanut butter cups at such a massive scale. Every step is carefully calibrated to ensure consistency across millions of cups. The heart of Reese's production lies in its state-of-the-art conveyor belt system. This complex network of belts and machines orchestrates the transformation of raw ingredients into millions of perfectly formed peanut butter cups. The process begins as the chocolate-coated molds, fresh from the spraying station, make their way to the peanut butter injection point. Here, precision-engineered nozzles deposit a carefully measured amount of peanut butter into each chocolate shell. The timing of this injection is crucial. Too early, and the chocolate might not be set enough to hold the peanut butter. Too late, and the peanut butter won't settle properly. The machines are programmed to deliver the perfect amount with millisecond accuracy, ensuring consistency across millions of cups. Temperature control plays a vital role at every stage of production. The chocolate shells must be cool enough to hold their shape, but warm enough to bond with the peanut butter. Meanwhile, the peanut butter itself needs to maintain a specific temperature to flow smoothly into the molds without compromising its texture. Sophisticated temperature monitoring systems constantly adjust conditions throughout the production line, maintaining the ideal environment for each step of the process. After the peanut butter injection, the cups continue their journey along the conveyor belt to receive their final layer of chocolate. This top layer seals in the peanut butter and completes the iconic Reese's cup shape. Again, precise timing and temperature control are essential to achieve the perfect seal without mixing the layers. The newly formed cups then enter a cooling tunnel. This temperature-controlled environment allows the chocolate to set properly. maintaining its temper and shine. The cooling process is gradual to prevent any sudden temperature changes that could affect the chocolate's structure or cause unsightly blemishes on the surface. As the cups emerge from the cooling tunnel, they're nearly ready for packaging. But first, they undergo a final quality check. Any cups that don't meet Reese's strict standards for appearance or weight are removed from the line. This ensures that only perfect cups make it to the next stage, wrapping. The wrapping process is another marvel of modern manufacturing. High-speed machines envelop each cup in its iconic orange wrapper. These wrappers have seen minor updates over the years, but their distinctive color and design remain instantly recognizable. The wrapping machines work at an astonishing pace, matching the output of the production line to ensure a smooth, continuous process. In recent years, Reese's has introduced seasonal packaging options and resealable bags to cater to consumer preferences. This flexibility in packaging allows for special holiday editions and larger portion sizes, adding variety to the product line without altering the core manufacturing process. Perhaps the most impressive aspect of the Reese's production line is its relentless pace. The factory operates 24 hours a day, 7 days a week to meet the staggering demand of over 40 million cups produced daily. This continuous operation requires not only robust machinery, but also a dedicated team of skilled workers and engineers who keep the process running smoothly around the clock. The scale of this operation becomes even more remarkable when you consider the consistency maintained across such massive production volumes. Every Reese's cup, whether it's made at 2 p.m. or 2 a.m., follows the exact same process and meets the same exacting standards. This level of consistency is a testament to the precision of the machinery and the expertise of the Reese's production team. Quality control is the backbone of Reese's production process, ensuring that every single peanut butter cup meets the exacting standards that have made this treat a household name. The quality assurance measures begin long before the first ingredient is mixed and continue until the final product is packaged and ready for distribution. Every batch of Reese's peanut butter cups undergoes rigorous testing to maintain consistency in taste, texture, and appearance. This process starts with the careful selection of ingredients. The peanuts, chocolate, and other components are meticulously sourced and tested before they even enter the production line. This initial screening helps prevent any subpar ingredients from compromising the final product. As the cups move through the production process, they're subjected to a series of checks at key points. Automated systems monitor factors like weight, shape, and color to ensure uniformity. Any cups that deviate from the established parameters are flagged for further inspection or removal. But it's not just about looks. Taste tests are a crucial part of the quality control process. Trained testers sample cups from each batch, evaluating them for flavor, texture, and overall eating experience. These experts have highly developed palates and can detect even subtle variations from the Reese's standard. Temperature control plays a vital role in maintaining quality throughout production. Sensors throughout the facility continuously monitor and adjust temperatures to ensure optimal conditions for each stage of the process. This precise control is essential for achieving the perfect chocolate temper and peanut butter consistency that Reese's fans expect. The quality assurance team also conducts regular checks on the machinery itself. Even minor variations in equipment performance can affect the final product, so frequent calibration and maintenance are essential. This proactive approach helps prevent issues before they can impact production. Despite the high-tech nature of modern manufacturing, human oversight remains crucial. Experienced quality control specialists visually inspect samples from each batch, looking for any imperfections that automated systems might miss. Their trained eyes can spot subtle flaws that could compromise the Reese's experience. Any cups that don't meet the stringent quality standards are identified and removed from the production line. This might seem wasteful, but it's a necessary step to maintain the brand's reputation for consistency and quality. Reese's understands that a single bad experience can turn a customer away, so they take no chances when it comes to quality. One of the most remarkable aspects of Reese's quality control is how little the core manufacturing process has changed over the years. While the machinery has certainly been upgraded and production volumes have increased, The basic steps of creating a Reese's cup have remained largely unchanged for nearly a century. This consistency and process has played a significant role in maintaining the product's iconic taste and texture. How do they maintain such high standards across millions of cups produced daily? The answer lies in a combination of cutting-edge technology and time-tested expertise. Automated systems provide constant monitoring and data collection, allowing for real-time adjustments to the production process. This data is then analyzed by quality control experts who can identify trends and make proactive improvements. The quality control system at Reese's is designed to be both rigorous and flexible. It can adapt to changes in ingredients, seasonal variations, and even the introduction of new product varieties. This adaptability ensures that whether you're enjoying a classic Reese's cup or trying a limited edition flavor, you can count on the same level of quality. From raw ingredients to iconic orange wrappers, we've seen how Reese's transforms simple components into millions of perfect peanut butter cups daily. This massive operation relies on precision engineering and cutting-edge technology to maintain consistency at an unprecedented scale. It's no wonder Reese's peanut butter cups are the top-selling candy in the United States, outperforming competitors like Snickers and Kit Kats. The complex machinery, rigorous quality control, and carefully calibrated processes all contribute to the treat's enduring popularity. As Harry Burnett Reese once said, "It's the combination of the rich chocolate and creamy peanut butter that makes it so special." But now we know it's not just the ingredients, it's the intricate manufacturing process behind them.